Okay, so just a couple of things. We are going to wrap up 2.8 today. Before we do that, we are going to talk about 2.6, that being residuals and data sets. So we'll talk about that in just a second. A few reminders. Remember, tomorrow morning by 8:05, that is the deadline for anybody still wanting to participate in the extra credit using that Trig crossword puzzle. If you need another copy, let me know. I do have it on the website as well. And then Friday at the end of 8th period, we're going to have our gas leak evacuation drill. Okay. Well, does anybody need a copy of 2.6's assignment? Anybody else? Okay. So 2.6, I gave this to you Thursday or Friday at the end of last week. It was one of those 2 days. Okay, so it's going to look like this. Okay, so we had data sets, need more copy? Where we talked about different strategies for determining if it was a linear, quadratic, or exponential, what was the best model that would react to that. And then we also had residuals. Can anybody tell me what a residual was? It was the difference between something. There you go. The difference between the actual value and the predicted value. So we'll go ahead and do one just to make sure that everybody remembers. So let's look at number 5. A quadratic regression was used to model a data set. The residual plot is shown above. Which of the following statements about the appropriateness of the model is correct? So when we're looking at a residual data plot like this, is it a good or a bad thing if we see a pattern? Bad. When we're talking about a residual plot, if we see a pattern, that means the model you used is not appropriate. You want to use something else. So we want to see just a bunch of points in space. So this one is definitely going to have a pattern to it. So that means that A and B are out. So based on the answers here, because it shows a quadratic pattern, that's the one that I would choose. So I know that's kind of counterintuitive because in mathematics, we actually look for patterns to kind of help us establish things. But with a residual plot like this, if you see a pattern, that's bad. Okay, you want no pattern. You want the randomness. That means you've got a good model. Okay. Now that's the only one I kind of wanted to do to make sure that we remembered that. Was there anything else on 2.6 that we wanted to look at? Anything else on 2.6? Fair. What's that? 9. Let's take a look at 9. Okay. All right. A set of data was used to create a linear, quadratic, and an exponential regression model. The residual plots for the 3 models are shown above: linear, quadratic, exponential. Based on these 3 residual plots, which of the following could be an appropriate model for the data? Okay, so what answer can I eliminate immediately? We haven't even gotten to them yet. Okay, we have not talked about logarithms yet, so that is out. Don't worry, when we get back from spring break, that is exactly what we're going to start discussing. Okay. Oh, so I'm going to go through these one at a time. Let's look at the linear plot. Pattern or no? There's definitely a pattern. Remember, we said a pattern was a bad thing. So because there's a pattern, it can't be linear. So I'm going to go ahead and mark out the only linear answer. Okay, well, let's look at quadratic. Do I see a pattern? Yep, looks like some kind of polynomial to me. So again, a pattern is bad. That means it can't be quadratic. I'm going to mark out the only quadratic answer I have. Well, the only answer left by process of elimination is the exponential. If we take a look at the data plot, or this residual plot, I should say, there's no pattern visible. It's just a bunch of random points. That's what we want. That means that the model is going to be good. It's appropriate. Okay. Vera, is that good? Okay. Anything else? Number 7. Oh, 10. Okay, sorry, 10. 10, 10, 10. Okay. So let's take a look. Mr. Passwater loves to invest his money in mutual funds. Over the past 20 years, he's closely tracked how his account grows and noticed that each year his account grows by approximately 10.4%. If Mr. Passwater wants to find a function that models the amount of money in his account over time, should he use a linear, quadratic, or an exponential model? Okay, well, what do we think? What's that? It is going to be exponential, but why? How is the money growing? Okay, so it's exponential. Now, remember when we were looking at data sets and we identified the y values as doing something? We said it was exponential. Okay, how is his money growing? It's changing what? Start with a P. It's changing proportionally. There we go. I mean, it's not changing at a constant amount, so that's why we're going to remove the linear. Okay? And then quadratic, there's just one particular function you would use. It's not going to grow based on the previous value you've got. So the only one that makes sense is going to be exponential. And Harrison, you asked about that. Okay, does that make sense? Anything else? Number 2. Okay, so number 2, selected values from several functions are given in the tables below. Sketch the scatter plot for each table, then determine if a linear, quadratic, or an exponential model is most appropriate. Okay, so if we believe that the data set is linear, then we should see a roughly constant rate of change. Remember, I said roughly, it's not going to be perfect. Okay, if we think it's quadratic, then we should be able to see some type of symmetry. The y values are going to increase first and then decrease, or they'll decrease and then increase. If we think it's exponential, then there might be some kind of change based on multiplication. And we just talked about that. We're looking at something to change proportionally. Now, unfortunately, here, if you take a look, going from -2 to 0, that's 2, 0 to 2, but then it goes from 2 to 5. So this isn't exactly the same. It's not equal interval values. I mean, there's only one of these that's off, so you might still be able to go with that. But because it's not consistent, I would just go ahead and take a look at the scatter plot on this one and then make our decision. So -2, 1/2 would be right here. Then we have 0, 1. Then we have 2, 2. Okay, then we have 5, 5.6. Okay, so let's say right about there. I need to change my screen. And then 7, 11.3, maybe right about here. All right, so let's say it looks like that. Well, what are we thinking? Well, it's definitely not linear. Okay, what are we thinking? Exponential. There we go. Now, I'm going to go ahead and kind of confirm this in the table, but like I said, you know, it's not going to be consistent. It looks like we're changing by doubling it, okay? Multiplying by 2, because 1/2 times 2, well, that's 1. Okay, 1 times 2 is 2. 2 times 2 is going to give me 4, but see, we don't know what's happening at 4. See, it goes straight from 2 to 5. Does that make sense? But again, even with the other one from 5 to 7, that still does kind of confirm it. But again, just because it wasn't consistent, that's why I decided let's focus on the scatter plot. But I would definitely say exponential. So let's step out 2. Reed, does that make sense? Okay. In fact, I'm kind of surprised that the resource did that, because in all the notes, every one of those inputs had equal length intervals. But then several of these, they went ahead and changed that. I don't know if that was intentional or maybe someone missed it, but I don't know. Okay. All right. Anything else? Good. This is the most questions I've had all day. This is fantastic. Okay, we're good. All right. Well, let's go ahead and put that to the side. Okay. Let's pull out the 2.8 notes. So we are on the 3rd page at the bottom. Let's see, who wants to bring it over here? Who needs a copy? Here we go. William, would you pass that? Anybody else need a copy of 2.8? So we started talking about inverses yesterday. Okay, we should be able to finish today. So we're on page 3 at the bottom. Excuse me. All right. Well, what is it that inverse functions do? Well, if you plug a number into a function, it generally will output a new number. For example, if we plug a 2 into 3x minus 1, we get the y value of 5. Now, if we take that answer and plug it into the inverse, we're going to get back the original 2 that we started with. Okay, the reason is because inverses are going to undo what the original function does. They're always going to use the opposite operations. So if the original function adds, well, then I can expect the inverse to subtract. If the original function is multiplying, I can expect the inverse to what? Divide. Exactly right. Okay. Now, if we plug x into a function and then plug the output into the inverse, we should end up with x again. So this leads us into our next set. Okay. Yes or no, if we're given two functions, are they going to be inverses? Well, two functions f and g are inverses if and only if the composition of those two functions in both directions gives me x. Now, if we go ahead and write that with the notation we've been using, we want to show that f inverse of f and f of f inverse both equal x. And it's not a coincidence that it happens to be x itself. What was the line of symmetry that we were using when we graphed an inverse? Remember, it was y equals what? It was y equals x. It's the linear parent. Okay, so that is exactly why we should get it. Now, it has to work in both directions. Even if it's something as simple as a negative, if you get a negative x, they're not inverses. It has to be just positive x. Okay, well, let's look at an example. Okay, example 6. So f and g are functions given to us. Determine if they're inverses. Now, step 1, it says find f of g of x. Now, they're not giving me a numerical value. Does anybody remember, we looked at this a couple days ago, if they just give me x, how do I actually do this? I'm going to put the whole function into the other. Now, because g is the inside, I'm going to go ahead and take 1/2 x plus 3/2. That's what I'm going to substitute in. Okay, so 2x becomes 2 times 1/2 x plus 3/2, and then we have the minus 3. And let's do a little bit of algebra. Let's see what we get. Okay, Ryan, you okay? You want to get a drink? Okay. So if somebody distribute for me, what would I get? 2 times 1/2 x. X plus 2 times 3/2, 3, and then we have the minus 3. Well, those are going to cancel. So there we go. It does equal x. Okay. All right. So I guess we're done. They're inverses. Why not? Matthew, why are you shaking your head? There you go. It has to work in both directions. It is very possible for the composition to work one way, but not the other. So you always want to check it. So when we want to take a look at g of f of x, f is now the inside function. So I'm going to take 2x minus 3. That's what I'm plugging into g. Okay, so this is going to be 1/2 x. So that's 1/2 times 2x minus 3. And then minus 3. Oh, looking at the wrong one. That's a plus 3/2. Plus 3/2. Okay. So if I go ahead and distribute the 1/2, it looks like I'm getting x minus 3/2 plus 3/2, which again, we have opposites. So I do get the x that I'm looking for. So yes, these are inverses of each other. Okay. All right, so that's pretty easy. Now it says, note, sometimes we got to use a restricted domain to ensure two functions are inverses. Okay, and there's a couple of reasons for this, so we'll talk about that before we do this. It says show that h and k are inverses where x has got to be greater than or equal to 10. Okay. Well, here's the thing. Give me a number less than 10. Okay, 9. So let's go with 9. Now, if I plug 9 into h, 9 squared plus 10, well, that's 91. We actually get an output. What happens if I plug it into k? 9 minus 10 is a negative 1. What happens when you take the square root of a negative? It goes imaginary. Okay, so we're going to avoid that. Also, just think about it graphically. X squared plus 10. This is the quadratic parent. Just shifted up 10 units. Okay. Now remember, if I were to go ahead and reflect this across, the yeah, I almost said the x-axis, the linear parent y equals x, I'm going to get the inverse relation, right? Okay. Can anybody tell me, what does the square root of x minus 10 look like? Or let's just start at the beginning. What does the square root of x look like? You might draw it for me in the air with your finger? Yeah, there you go. It just looks like half a parabola. So this is half a parabola. It's just going to be shifted 10 units to the right. So if I start here at 10, okay, we see what the problem is? I started with a full parabola, but when it's reflected, I'm not getting that full parabola. So that's why we have to restrict it. Okay. All right. Well, good. Well, let's go ahead and set this up. So let's do h of k of x first, and then we'll do k of h of x right after that. Okay, so who wants to come on up and show me h of k of x? So many hands, I just need one. I got the wheel up. Oh, Vera said she'll do it. Okay, so come on up, Vera. Oh, sure. Yeah, you betcha. Okay, so you're going to show me h of k of x. Which is just x. Okay, so we're halfway there. Okay. All right. No, I'm sure there's going to be another person. In fact, let's do it this way. Since you volunteered, who would you like to see do the other composition? Like almost nobody is making eye contact with Vera. That's okay. If you don't feel comfortable choosing, I got the wheel of destiny. So Vera, what do you want to do? You don't want to choose? Okay, that's fine. That's okay. That's okay. I've got it pulled up. Okay. So we got our 16 people in here. Let me go ahead and give this a shuffle. Shuffle. Here we go. Who will it turn out to be? Okay, it's Addie. Okay, now Addie, you haven't been here in several days. Do you feel okay doing this? We could try, okay. Actually, what I found from years of experience, somebody who volunteers another person secretly wants to do it themselves. Ryan, does that mean you want to come up? We'll save it for later. Oh, okay. So I'll get you up here in just a little bit. Okay. So now we're plugging the radical into the quadratic. So the square root of x squared plus 10 minus 10. Okay. All right. We got our x. Okay, there you go. So yes, they are inverses of each other. Okay. All right, so questions. Now, I went through early this morning and I decided we didn't have to do every one of these problems. Number 8 is the same type of problem. Does anybody feel they want a little more practice, or can we move ahead? Okay, I'm going to take that as we're good. All right. So here we go. This is what we know so far. This is inverse functions part 2. If f and g are inverses, then g equals f inverse. Or we could even say f equals g inverse. Okay. Number 2, if xy is a point on the graph of f, then yx is a point on the graph of g. Number 3, with inverse functions, all the x and y values are switched. So the graphical behaviors in terms of x and y will also be switched. And for example, the domain of f becomes the range of the inverse. And you're actually going to see that in just a moment. Number 4, a continuous function will only have an inverse function if it is strictly increasing or strictly decreasing. If a function changes from increasing to decreasing or vice versa, it will not pass the horizontal line test. And remember, we talked about that yesterday. Remember, that's what we call one-to-one. We're trying to see if any value of y repeats. So that means that the inverse will not be a function. Okay, so with these in mind, here's our next problem, or set of problems, I should say. Now, let f be a continuous function with selected values in the table, should be above. Let g be the inverse of f, such that g equals f inverse. Find the following values if possible. Okay, so the first one doesn't even involve inverses. It's just identifying values from the table. Now, because f of 0 is the innermost function, that's what we're going to go ahead and start with. Okay, so Quinn, I'm looking at the table. What is f of 0? 1. Okay, when I plug in 0, I get the y value 1. Now, what we were talking about the other day, when we're working a composition, this output, the answer to the first one, is now going to plug directly into the next one. So now I'm trying to evaluate f of 1. Okay, and Alexandra, can you help me out with that? What's f of 1? There you go. Plug 1 into f, you get negative 1. There you go. Now, when it says part B, for B and C, we're going to go ahead and do something a little different. Because what do we know about f and g? Remember, they're inverses, right? So I've got the table already created. I flipped the x's and the y's, but before I go ahead and reveal the table, I want to show you that you don't actually have to do that in order to see the table. Now remember, we've got our x's in the top row, we got our y's in the second row. We're going to switch the x's and the y's. So if I want to evaluate function g, then I'm going to say the bottom row, those are the x's for g, and the y values would be the top row. So instead of evaluating like function f, we went it kind of from the top down. We're going to go from the bottom up. So g of negative 3, so I'm looking at function g. If I plug in a negative 3, I should get a 4. Okay, see, we're evaluating the table up because we're looking at it as an inverse. Does that make sense? So what would g of 6 give me? What's that? Close. Now see, now if we were given f, that's a horrible f. Let me write that again. Now if we were given f of 6, okay, see, these are the inputs for function f, so if I plug a 6 into f, I am going to get negative 7, yes. But because we're looking at this as the inverse g, we're going from the bottom up. So this is my x, so there would be what I'm looking for. Now, I just wanted to go ahead and kind of show you a different way of doing that. I mean, if you really want to, it only takes a few seconds to actually map out the table, so we can use it as well. Okay, so D, E, and F. Okay, go ahead and take, I think I was giving the other classes a couple minutes to run through those. So evaluate for me D, E, and F, and then we'll come back and talk about it in a second. Now remember E right here in the middle, remember that little circle, that still means composition. So this is the same as if I were to write F inverse of F of negative 2. It's still the same. We're at a 20. Actually, yeah, we should have a little bit of time in class today. We don't have much more to do. You got your cash? What do I do with my paper? Oh, we're on 4 DEF. And then we'll talk about it. Is that you? The hair's different. Okay. So why don't we go ahead and run through? We'll get the answers first, and then if we need to go back and talk about any of those, we'll go ahead and do that. Okay, Bailey, can you help me out? What'd you get for D, G of -1? 0. Okay, that is 0. Good, 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 good. Okay, Audrey, what'd you get for E? -2. Yes. -2. And just go ahead and point out, not only remember you can write the composition this way, we know that G is the inverse of F. So you also could have written it as G of F of -2. There's actually several different ways you could have done that. Okay. And Akil, what'd you get for F, the F inverse of -3? 6. Close. Matthew, can you help him out? Didn't get that far. William? 4. Okay. So there's a couple of ways we could do this. F inverse, remember, what's the inverse of F? Remember, it was G, right? So all I really need to do is take G of -3 so I could look at the table, or we'd actually seen that one just a moment ago. Okay. Did anybody want to take a look at D or E? Okay, which one? Let's do D. So it says G of -1. So here's function G. So let's start with G of -1. Okay, so in function G, okay, if I plug in a -1, what am I getting? 1. Okay, now I'm going to take that 1 and I'm going to plug it right back into function G. So now I want G of 1. Okay, so I come back up here. If I plug in the 1, what do I get? 0. Okay, all right. Did anybody want to take a look at E? Okay, I'm going to go ahead and get these dots out of here. Okay, so moving on. Number 2, it says the function k is defined over the interval from -4 to 11. So this is k right here. So this function k. So k inverse is going to represent the inverse of k. Well, the first thing I want, what's the minimum value of k? All right, now remember, when it says k of x, that function notation, that's the output. That's the y value. So basically, we're asking what's the minimum or smallest y value it has? What would that be? -3. There we go. Now, what's the minimum for k inverse? We'll see this graphically in just a second, but I do want to go ahead and show you something. Let's say for function k, we want to find the domain and the range. Now, we already have the domain. We see how wide it is. We said it's from -4 all the way to 11. Okay. But can anybody tell me, what's its range? How tall is it? It goes from -3 to 6. So I'm going to say -3 less than or equal to y, less than or equal to 6. Now let's do the same thing for the inverse, the domain and the range. So remember, what's the key idea for an inverse? We're going to take x and y and do what? We're going to switch them. So these x's right here, the domain, they're going to become the y values, the range in the inverse. So I'm going to say -4 less than or equal to y, which is less than or equal to 11. Okay. These y's in the range, they're going to become the x's, the domain in the inverse. We're just switching them. So this is now going to be -3 less than or equal to x, less than or equal to 6. Now, if we're talking about a minimum or a maximum value, we're talking about the range. So what's the minimum value for the inverse? -4. There we go. Is everybody okay with that? Okay. Now, speaking of, let's go ahead and get the graph real quick. Okay. So let's take these points. So, for example, -4, -3, that's -3, -4. And I'm just going to move right along the segments here. So 4, -1, that's a -1, 4. And I've already got these little segments ready to go. Okay, then we have 6, 4, that would be 4, 6. Okay. There we go. And I did measure this before coming in. Okay. So if I go ahead and take 11, 6, the end of this segment will be the point 611. Okay. So I did measure that with the grid that I have here. Okay. And then you'll notice if you go ahead and put the line of symmetry, the two parts are going to come together perfectly. Okay. And you'll notice this is K inverse. And the minimum is -4. Okay. All right. Well, now that I have K inverse, I can go ahead and answer B. So it says find K inverse of 6. So remember, I'm looking at the graph that we just created. Okay. So I would go ahead and locate my 6. It's right here. And then I would go ahead and draw a line from my X to the graph. So I'm going to go straight up until I hit the graph, and then I'm going to go straight over. Well, what Y value would I have there? Remember, what did the endpoint correspond to? 6 and then what? 11. Now, I can easily go ahead and do the same thing for the other one, but I kind of want to show you a different perspective. Could you still get the answer without having the inverse graph? What do you think? Yes. Yes. Okay. Here we go. So think about it this way. If I'm trying to evaluate K inverse of 4, what does 4 represent? Is it X or Y? It's still X. I'm plugging it into the function, so it represents the X value. So on the inverse, I would have this point 4, but I don't know what the corresponding Y value is, right? Well, let's apply the idea of an inverse. On the function K, these are just going to switch, right? So I know this X value of 4 is now going to become a Y value of 4. So I just don't know what its corresponding X is. So if I go back to the graph of K, see, I have a Y value of 4 right here. If I were to go over to the graph and hit it, see, I'm getting my answer of 6. So that one right there has an answer of 6. Now, even if I had just gone to K inverse, if I plugged in a 4, gone straight up to the graph, see, I'm still getting that right answer. Okay. Again, I just wanted to go ahead and show you a different perspective on that. Oh, you had to say something. Okay. Ryan, you okay? Do you want to get a drink of water? Are you sure? Because you look like your head was about to hit that desk there. Okay. All right. Now, number 3 is the same type of problem. Okay. Did anybody want to take a look at it? Okay. Then we are on our last problem here. Okay. Number 4. Once we're done with this, we are done. The function g is defined over the interval from -3 to 10, as shown above. Let g inverse be the inverse of g. Values of the increasing function h are given in the table above for selected values of x. Okay, so I already showed you the other way by looking at the table from the bottom up, but for this one, let's just, I just went ahead and drew the table again. There's h inverse. I switched the x's and the y's. Okay. Let's go ahead and graph g inverse. Okay. So I'm going to go ahead and start here. So 10, negative 1 becomes negative 1, 10. So there's a point right there. That connects to 6, 1 would be 1, 6. Okay. All right. And I did measure it, so this is going to be accurate. Okay. Then I have the 0.34, so that's 4, 3. So this segment connects here. And we're going to finish up. We have negative 3, 6. So that's 6, negative 3. There we go. So if I were to draw my line of symmetry, again, those two parts are coming together perfectly. Okay. Cool, 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 cool. All right, let me go ahead and label these. So this one right here, the original graph is G. This new one, that's the inverse. Okay. Now, the first one does not use any inverses, okay? G of H of 6. Okay, what's H of 6? Okay, plug in 6, we get 10. That 10 is going right into G. What's G of 10? Okay, so here's 10 right here. What's the corresponding Y value? Negative 1. Okay. All right. So I'm going to go ahead and give you a minute. I want you to try these last examples, B, C, and D. Okay. We'll get the answers. We'll talk about them if needed. That's all we got. That'll be our day. All right. You may not be done with all of them, but that's okay. So B, G inverse of H of 0. Naya, what you got? It is 4. Okay. So like I said, we'll get the answers, and if we need to go back and talk about them, we will. Okay. C, H inverse of G of 8. Okay. Vera, what'd you get for that one? Got mixed up? Okay, that's okay. Quit. It is negative 1. Okay. And we'll go ahead and finish up. William, what'd you get for H inverse of G inverse of negative 1? Oh, we got mixed up? Okay. Reed, can you help him out? 6. There we go. Okay. Would we like to talk about any of those? Anybody got any questions? All right. Well, you picked up the assignment on the way out. This isn't going to be due at any one time. Definitely, don't take it over the break because I want you to relax and recharge your batteries. But you do have some practice problems if you need those. Okay. All right. We are done.